Hello again and welcome back. In this lesson, we're going to cover the different storage formats used in GIS software with an emphasis on ArcGIS specific data formats. By the end of this lesson, you'll be able to use and communicate about storage workspaces and data formats, and you'll be able to decide the appropriate way to store data in your own projects. When I say storage workspaces and data formats, I want you to think of file types, where image files have formats you may be familiar with, such as JPEG, PNG, GIF, or GIF, and TIFF. GIS data has a whole new suite of formats, and these formats affect what we can do with the data. A file format provides structure for storing your data and allows that data to be read by multiple software packages. The file format also contains information that describes the data, or the metadata as we learned, as well as the data of interest. But data formats aren't all equal, and in most disciplines come with trade-offs since the format you store your data in defines many of the capabilities. While your GIS software won't let you try to save your data in a completely incompatible format, you need to know about the options available to you so you can effectively use and communicate about your data. There are many types of file formats for GIS, but in this lesson we'll focus on the three most common for a typical GIS analyst using ArcGIS. These file formats are shapefiles, personal geodatabases, and file geodatabases. As you get more involved in specific workflows or in other software or web GIS, you'll learn about other formats, but these three are most important to you right now. These all get treated almost the same way once they're loaded into ArcMap, even though the underlying storage technology is very different, and in practice, that's what we work with. Let's start by taking a quick look at shapefiles. Shapefiles store only vector data types, so points, lines, and polygons, and only a single feature class is able to be contained in a single shapefile. That is, there's only one attribute table and one meaningful type of feature data in the shapefile. They are very widely supported, and in fact so widely supported that people often use the term shapefile to mean feature class in the way that we often say post-it note when we mean sticky notes. Just as post-it notes are a particular brand of sticky note, shapefiles are a particular type of feature class. Another thing to pay attention to about shapefiles is that they are actually composed of many files. In fact, I've seen as many as 8 or even 9 component files making up a single shapefile. There are additional files that can be created by other pieces of software as well in order to speed up use of shapefiles. Some core parts of the shapefile are the .shp portion, which defines the actual feature information, the .dbf portion, which describes the attribute table, and the .prj file, which specifies the projection information for the feature data. If you want to send people shapefiles, you need to zip up all of the files with the same name and that have different extensions and send them off all of those pieces so that they can load it into their software. Unfortunately, shapefiles are getting pretty old, and they're based on a pretty old database technology that limits some of their features. First, the field names in a shapefile are limited to 13 characters only, which doesn't initially sound that bad until you try to be very descriptive in your field names. The result is that people oftentimes put multi-letter acronyms that don't necessarily make obvious sense to everyone else as their field names, and you need good metadata to help tease out what those names mean. Another issue is that shapefiles are limited to 2 gigabytes per component. Initially, this is enough, but for large data sets, your data table or your spatial data can quickly fill up to that limit and you'll run into problems. We can work around some of the limitations of shapefiles by using geodatabases instead. Geodatabases are a type of container that stores multiple feature classes. A simple way to think of them is like a folder that contains feature classes, but they're also much more than that. Generally speaking, in GIS, a folder or database to store spatial data in is called a workspace. Geodatabases are a type of workspace, and as such, we can store rasters, tables, vector feature classes, and other important data inside of them. In the desktop GIS world, there are 2 primary geodatabase types, though there are others as well. These are the personal geodatabase and the file geodatabase. Each of these geodatabase types lets you store raster data, vector data, tables, and a number of other Esri-specific data types inside of them. They allow you to keep all of your data in a single container and organize it in ways that provide structure that becomes useful for more complex projects. Personal geodatabases in particular are useful for the desktop analyst, largely because they are a single file, so it becomes easy to share your database with someone just by sending them that one file. Their primary downside is that they are also based on an old storage technology, so they also have a 2 GB file limit. This time it's for your entire database though, not just for a single feature class. Due to the greater compression achieved in personal geodatabases, you can still store quite a lot of data in them, but the 2 GB file size limit is something to watch out for. The feature that makes personal geodatabases more or less indispensable though is that you can open them up in Microsoft Access and use them as a standard database, run queries, make table relationships, and do data entry, run reports, etc. Anything you can do in a normal Microsoft Access database can be done inside of a personal geodatabase. This makes them really powerful for all kinds of workflows and small projects. And for this reason, I frequently do use them for small and medium-sized projects. Once you need to store large data sets like rasters though, file geodatabases become a really useful workspace. Their limits are huge, so huge that you will run out of disk space on your computer long before you hit them. While they show up as workspaces when used in ArcGIS, on disk they are an incomprehensible folder full of files as shown here. You should not put anything else in this folder or otherwise modify it outside of ArcGIS. Let ArcGIS manage the data inside of it. Should you want to send this geodatabase off to anybody else though, you should right-click on the folder and zip it up. And then you could send off the zip file to other people to decompress and then use the geodatabase. In general, both personal geodatabases and file geodatabases use less disk space for the same data compared to shapefiles. To demonstrate, I have 3 copies of the same dataset here. One is a shapefile and a copy in each of these geodatabases, as you can see over here on the left. If we look at the size of each, the shapefile is largest, the personal geodatabase is smaller, and the file geodatabase is smallest. Data in geodatabases also runs faster in most instances. You'll notice the speed difference when you start displaying larger complex datasets in ArcMap. Once you are symbolizing by attributes, geodatabase feature classes render much more quickly and will save you time in the long run. So now, the important question. Which one of these should you use? The real answer to that is whichever fits your workflow best. There are no hard and fast rules on this, and I find myself using all of them to some degree, with file geodatabases being my go-to format. As a default, given the trade-offs, I recommend storing your data in geodatabases too. My reasoning is that shapefiles limit the names of your fields in the attribute table to only 13 characters, as we talked about before, and the cryptic names that come out of this can create problems for working with others on your project. In contrast, I've never hit the limit on the length of a field name in a file geodatabase, and I tend to give my fields long names so that it's easy to know what they are and they're easy to share. One last thing I want to leave you with, because we're out of time on this, is that I suggest you go and take a look at what each dataset looks like on your hard drive, as a shapefile and as a personal geodatabase and as a file geodatabase. You can explore them in ArcMap or ArcCatalog, and also if you open up Windows Explorer. Get used to the differences of storing and viewing them in each situation so that you're more familiar with receiving them and sending them off in the future. Okay, that's it for this lesson. In this lesson, you learned about the 3 most common types of data formats used in ArcGIS. We also discussed the different properties of each one so that you can better choose what to use in your projects. In the next lesson, we'll begin discussing how to structure your attribute tables to get the most out of your data. See you then.